Okay, students, so there are so many questions that why the standard form equation of ellipse is x square upon a square plus y square upon b square equal to 1. So here I am going to solve or derive that equation for you. So first of all, we should know that what is an ellipse. Okay, the definition of ellipse is that it is the locus of a point moving in a plane such that it's the ratio of its distance from a fixed point called focus to the distance from a fixed line called directrix is always constant. Okay, so here in our diagram, the fixed point, the focus is S. So I am calling this as focus, and this is our directrix. Okay, so there are always two directrix and two focus. This is the definition of ellipse, and the constant that we are talking about is called eccentricity. So in case of ellipse, eccentricity is always less than. Okay, so following the definition, if we take one point as A on the curve on the ellipse, so we can get SA divided by AM is equals to E. So A is a point on the curve and SA would be the distance from a fixed point because S is the focus and AM is the distance of that point from the fixed line, which is our directrix, and that is equal to E, the eccentricity, and the ratio is always less than 1. From here we can get that the distance SA is equals to E times of AM, and this stands to be our first equation. Okay, now I am assuming one more point. Let's say there is one more point A dash. Okay, so here A dash, we will get S A dash, the distance of A dash from the fixed point S only, and again its distance from the directrix on the same side of the focus, that is A dash M, is also equal to E. So we get S A dash is equals to E times of A dash M. Okay. So now from these two equations, first of all we are going to find out what are the coordinates of the focus, and then we are going to find out the equation of the directrix, and from there we can go on further to derive the standard form equation of the ellipse. Okay, so first of all let's focus on finding out the coordinates of the focus. Now for that we are going to add both the equations. First step is simply add equation 1 and 2. So we get S A plus S A dash is equals to E times of AM plus A dash M. Okay, so as you might have figured out that SA plus SA dash, SA is this much and SA dash is the remaining distance, so we are going to get AA dash is equals to E times of, now AM plus A dash M. AM is this distance and A dash M is the total distance from here to here. Okay, A dash is equal to E times of M into M dash. Now AA dash is this distance we are taking this distance as 2a and we call this distance as major axis. So 2a is equals to E times of twice of C into M. Okay, so CM and CM dash distance are same, so MM dash is twice that of CM. So we can cancel out 2 from here and we get CM is equals to A by E. So this distance CM is A by E. That means the equation of directrix stands out to be x equal to minus A upon E and x equal to plus A upon E. So this is the equation of the directrix. Okay, so this directrix is x equal to minus A by E and this directrix is x equal to plus A by E. Okay, so from here we can get that point M is A by E comma 0 and point M dash minus is A by E comma 0. Okay, so we can get the distance of point M and M dash from the center, and center being considered as the origin in this case. Okay, so now let us find out what are the coordinates of the focus of the ellipse. Okay, so to calculate the coordinates of the focus of the ellipse, that is the coordinates of point S and S dash, we are going to again utilize the first two equations that we have derived earlier, that we have written earlier actually. So here second step is to subtract equation 1 from equation 2. Okay, so if we subtract, we can write it as SA dash minus SA is equal to E times of. Okay, so subtraction. Now SA dash minus SA. So you can look at the figure and see that SA dash is this much, this whole distance, and SA is this much. Okay, so SA dash minus SA will be equal to S into S dash. Okay, because AS is equal to S dash A dash. Alright, that is equal to E times of again A dash M minus AM, that is equal to A dash. Okay, so this you can figure out from the figure because it is 100% symmetrical on both the sides. S dash is, we can write it as twice of CS is equal to AE into 2A. AA dash being the major axis, the distance is 2A, so we can cancel out 2A and we get C as CS as AE. Therefore, the coordinates of focus S are AE comma 0 and S dash is plus AE comma 0. So these are the coordinates of the focus. Focus, this is minus AE comma 0 and this is plus AE comma 0. Okay, so this is our coordinates of the focus. Now as we have got the coordinates of the focus as well as the equation of the directrix, so now we can go forward to find out the standard form equation of the ellipse. So for that I am considering a point, let there be a point, let a point P x comma y exist on ellipse. Okay, so the condition would be that its distance from the fixed point, this SP distance, and its distance from the fixed directrix, that is the perpendicular distance. This perpendicular distance, let's say this is point R, so PR should be equal to E. Okay, so this is the condition of ellipse, that the ratio of the point from the fixed point and to the fixed line is always equal to E. Now SP distance, because point P is x comma y, so we can find out that SP distance is under root of, applying the distance formula, we will get x plus AE whole square plus y minus 0 whole square divided by, now distance of point P from PR will be equal to A by E plus x. Okay, so why? Because CM distance is A by E and CS dash is x. CP distance is x. Okay, so it will be x plus A upon E. Okay, so that is PR distance. This is equal to E. So let's square both sides. We will get x plus AE whole square plus y square equal to E square into A by E plus x whole square. Okay, so if we further solve it, we will get x square plus A square E square. Simplifying the equation, we will get x square plus A square E square plus 2AEX plus y square is equal to A square plus B square x square plus 2AEX. Okay, so this gets cancelled and we will get x square plus y square is equal to x square minus E square x square plus y square equals to A square minus A square E square. Okay, so from here we will get so this is what we get after simplifying. So what we can do is we can simply divide the entire equation with this quantity. We get x square so this is what we get. Okay, so this get cancelled out by this and the this is the equation that we get after solving this. So this is actually the equation of ellipse, but you might have heard that we used to write x square upon a square plus y square upon b square. Now how this quantity is equal to b square, or what is that b? Okay, so simply if we put, if x is equal to 0 in this equation, we will get y as plus minus a under root 1 minus e square. So this value y is actually from here, this distance is we are talking about. Okay, so when for a semi-major axis, this distance is, the distance is a, so this is equal to b. Okay, and we call b as semi-minor axis, okay, or 2b or b dash as minor axis. Hence the equation becomes x square upon a square plus y square upon b square is equal to 1. So this is the equation of standard form equation of ellipse, is x square upon a square plus y square upon b square equal to 1. Okay, so we have learned so many things today in this video. Number one is the center of the ellipse. If we are taking it as the origin, then we get only the standard form equation of the ellipse. Okay, because there are other forms of equation of ellipse as well. The definition of ellipse tells us that for any point on the curve, on the ellipse, the distance from the fixed point, that is the focus, and the distance from the fixed line, that is the directrix, if we take the ratio, that will be a constant which is called eccentricity whose value is always less than 1 in case of an ellipse. And again, so starting from there, we have first step was SA is E times of AM. Second step was SA dash is E times of A dash M. Then we first of all added both the equations. When we added both the equations, we got the coordinates where the directrices lie in standard form. And if we subtract, then we get the coordinates of the focus. Okay. So these are the two major steps. Then A and A dash. The distance A dash is called as the major axis, and the distance B dash is called as the minor axis.